Hello everyone, this is Ms. Risk again with the last handout that's going to be on your test to review it. Gravity and acceleration part 2. And the two formulas for today are distance equals acceleration t squared over 2. And it gives you all the variables down here. And the second formula is the average velocity equals final velocity minus initial divided by 2. So number 1, how far will a rubber ball fall in 10 seconds? So we don't know the distance. The time is 10 seconds and acceleration for falling object due to gravity is 9.8 kilometers per second squared. And 9.8 distance equals to 9.8 times 10 seconds, the time, over 2. 9.8 times 100 because it's 10 squared over 2. So that's the seconds will cancel out and we end up with kilometers. 980 kilometers divided by 2 equals to 490. That's number 1. And number 2 is exactly the same as 1. So I'm going to do one type each. So I'm going to do 1, 2, 3, 4 problems for the 8 because the second problem is identical. So I'm going to move on to number 3. Number 3, how long would it take an object dropped from a window to fall a distance of 78.4 meters? Now we have to derive this formula from this formula. For this problem I'm not going to derive it, but next problem I will. The distance equals acceleration t squared over 2. You multiply, cross multiply, so you put multiply by 2, so it's going to be 2d, and then you're going to divide by a both sides. You end up with t squared, so you take the square root of 2d over a. But we're just going to plug in the values. So t equals to 2 times the distance, which is 78.4, divided by the acceleration, which is the same, 9.8 meter per second squared. Now the meters will cancel out and we have seconds squared. When you take the square root of second squared, you end up with 1 second. So 2 times 78.4 divided by 9.8 is 4. That's number 3, and number 6 is exactly the same as number 3. You can pause, write down, review, but I have to just do it quickly. Number 4, calculate the final velocity of a ball in problem 1. Now, I'm going to derive this. I don't expect you to derive it from here, but I just want to show you how we got it. We start with the distance equal acceleration t squared over 2. We're going to plug in the values or variables for acceleration, which is final minus initial velocity over t. Now, initial is 0 when you're dropping an object. And then we have whatever is left is final velocity over t. So you plug it in here. For a, it's final velocity over t. One of the t squared will cancel out with this t, and we end up with final velocity. Then distance equals final velocity times t divided by 2. You multiply both sides by 2 divided by t. You get final velocity equals to 2d divided by t. On the test, you're going to have the set of problems, you just have to know how to apply them, so you don't have to derive them. So we start with the formula that we just derived. Final velocity equals to 2d divided by t. So from problem number 1, d was 490 kilometers and the time was 10 seconds, so you just plug in the values. So 2 times 490 divided by 10 equals 98 meters per second. Okay, that's number 4, and 7 is exactly as number 4. And then the last one we have to do was number 5. What is the average velocity of a ball in number 1? Again, the average velocity equals final minus initial divided by 2. Initial was 0. So for number 1, the final velocity, we just figured it out, 98 meters per second. So 98 minus 0 over 2 equals to 49 meters per second. And number 8 is exactly the same as number 5. And that takes care of the last handout on your test. Good luck tomorrow, and until next time, thank you.